Alright, welcome to Doozer Shop. We are making updates on the Colchester lathe apron. Last time I had it on SIP, and I had the feed rod in there, and was milling the casting, the wall of the apron for clearance, and I showed you guys all that. But now, what I'm doing is, well, I'll just take a handheld and I'll show you. I've got the SIP jig bore raised way up, and I'll show you what I'm doing. Kind of go over to the side here, and you can see my setup. I got the angle plate, my half pierce angle plate, and I've got the front face of the apron bolted on, and squared up. I don't know if the light is killing me. Alright, you can see this area here I have surfaced off, where it's not gray. There you go. That's the glare was worrisome that it was going to cause a problem. So the side of the apron wall wasn't flat, and I took a skim cut because you could feel it was just humped up, and so I milled all that off. I only took off maybe 40 or 50 thousandths. So there's 3 holes that are 3/8 thread. 1, 2, 3. Those were existing there, and I believe those were for a travel dial or a travel dial on the carriage. So I believe that was a bracket for that. 1, 2, 3. Okay. Now, that hole and that hole are holes that I put in, and that's going to be for a bracket to support. The bracket will support the rocker box that hangs down and keep it from hanging down too far. Let me kind of go around this side and I'll show you better what I'm talking about, I guess. Alright. So what's going to happen is I'm going to drill the other side and put a bracket coming out and put like a piece of bar stock through it, and it's going to come across and meet with another bracket on that side. I'm going to drill and tap holes. I'm going to flip this over and come back and give you guys a shot. So what that's going to do is keep the rocker box from falling down too far. It's going to keep it supported. So I kind of just milled this flat for no good reason other than I could, and it was fixtured up and it was easy to do. And you might ask, well, why didn't you just put a bracket on the existing holes, the 3/8 tapped holes that were there for the travel dial bracket? Well, I got to thinking about it. I could have. But I might actually want to go on eBay. I've been looking on eBay for a travel dial and put one back on here. I can make my own bracket. That's easy enough. So that was my thought with that, is to keep using these holes for a travel dial bracket. And you could see it had little set screw marks where it had like leveling screws in between them, because travel dial made their own cast aluminum brackets. And they knew they're going to be sitting on castings that weren't flat. So if you have a casting that's not flat, you need to have jack screws to level it next to the attaching screws. So that's what they did. But anyways, I'm seriously thinking about, 250 bucks is about what they're going on eBay. Might be a nice feature, I don't know. Or digital readout, but whatever. So I tapped these holes. These are 5/16, 18, 5/16, 18. What I did is I used the dial indicator and I centered up on my bushing. So these are in line with the center of the bushing, and I went over 2 inches drilled and tapped my hole, and another 2 inches and drilled and tapped my hole. I'm going to flip it over on the angle plate and do the same thing. Go over to it, you know, centered, in line, go over 2 inches, tap the first hole, go over 2 inches, tap the second hole. So that'll be for my bracket, for my support rod, to keep my my feed rocker from coming down, falling down too far. Now, Keith Fenner on his lathe, I know it's kind of hard to see because it's bolted to the angle plate. I believe he drilled and tapped some holes here, came down with a piece of bracket flat stock, came over and up the other side. So the goal is when this rocker box comes down, the handle doesn't fall too far down. So you need to support it. So instead of supporting the handle directly, like Keith Fenner did, I'm going to put a bracket on here, put just a piece of bar stock rod, maybe 1/2 inch, 5/8, whatever, and come across and support the bottom of the rocker box. So you don't see it. Maybe more elegant, maybe not, I don't know. And you know what? If these holes and these brackets don't pan out and it doesn't work, I'm just going to have additional holes for who cares, you know, just for another accessory idea, whatever, doesn't matter. So, yep, I got see, this is my poor boy travel dial, just an indicator. And I got one on the cross rail too, a 2-inch one. This is a 3-inch Federal on a magnetic base there. So that's what I've been doing. Nothing more complicated than that. It's pretty cool that this bridge on the SIP goes up pretty darn far. There's the ceiling. But see, all this work would be pretty darn easy. I could just plop this on the table of the Giddings & Lewis. But until I get the Giddings & Lewis 100% running, I'm using an angle plate and doing it on the SIP. So let me bring you back in a few minutes, and I'll show you having it flipped around and drilling the other side. All right, guys, I got you brought back here. I got the apron flipped over in the angle plate on the SIP jig bore. Pardon the indicator. Let me get you a good shot. All right, so I got this hole put in, and I got that hole put in. Now, like I say, they're in line with the bushing for the feed rod, and it's 2 inches over to that hole and 2 inches over to that tapped hole, 5/16 18. Now, I did not mill the surface flat because this side was pretty good, and that's why I got the indicator in there. I was surfing around the surface after I had tapped the holes, and it's pretty flat. You can see that. That's a well, 15,000. So it was within 5 thousandths when I was surfing around, basically. From that hole, and it kind of dipped about 2 or 3 thousandths, and then actually came back up to the same level. From that hole to that hole, it is right on within less than 1/1000th. So, and it drops off about 2 thousandths here, and if you go back on this side, it gains about 2 thousandths, and then slowly it gains about 15 thousandths over to here. But that's not that much. So I figure I could put some equal thickness washers, one there and one there, just to kind of float it a little bit. My plate. I got. I'll just have to put a plate on it, both sides. So like I say, there's the holes I showed you a few minutes ago, and you got I don't know if you can see it. Probably not. from the bottom, but definitely from the top. Got those holes in there. Like I said, again, it's going to be for a like a support piece of rod that goes all the way down to support the rocker for the power feed. Little rocker box there. So this time I couldn't get 2 clamp bolts. I got 1 clamp bolt in there. Kind of show you. All right, see, I got a little strap clamp to spread the load in the slot. And on the other one, you can kind of see, I'm trying to make out, yeah, C-clamp. I got a piece of aluminum on that boss, which is for the, I guess, the hand wheel. So the aluminum keeps the clamp from scuffing up the surface. And there's support on the inside, as you can see. The boss on the front side of the apron, so it's got a nice flat surface to register on the 90-degree angle plate. And then I got my clamp there. So, and it's supported pretty well. I'll show you. I got this square. So I'm going to focus on it while I walk around here. This is a Starrett square. This was my grandfather's square. It's a knife edge square. And actually my father used it in carpentry shop when he was in high school. So it was my grandfather's square. And he worked for the Ford plant. He worked for P&G Machinery in Buffalo. But anyways, what I do is I made sure the table was stone flat. You kind of switch hands here. So I put the square up against, let's see here. Right. And I doubt I can get you to see with the camera, but there is no daylight coming through that square. I mean, anyways, so I could indicate the casting on this whole surface for vertical, but for what I'm doing, that square gets me very close. That's the biggest machinist square I got. I want to get an 8-inch square. I think that's like a 5. I want to get an 8, and then I want to get a 10 or a 12, either Starrett or Brown and Sharp. But so that's my setup, and I got my my holes drilled there, and my holes drilled, on the other side. So that's basically it. And when I was getting into machining and engineering, I thought fixturing stuff was I hadn't done hardly any of it, and it was in my mind an obstacle. Like, how do I fixture anything that comes along? How do I fixture things and clamp them to the table and pick up bores? But a Kurt Weiss, that's almost cheating, as far as clamping stuff to the table. So once you get your T-nuts and your washers and your spacer blocks and your little rocker arm clamps, it's pretty easy to fix your stuff. I actually prefer it. So anyways, so that's the next step in the resurrection, reconfiguration, improving the Colchester lathe apron. Oh, one more thing I want to show you while I got the video rolling. So one of the cool things, so because this jig bore is made in Switzerland, it's kind of metric. I say kind of because there's some British stuff and there's some metric stuff. So I don't know if I showed this before. This is a beater bar for a plastic masticator.
And it's 16 millimeters exactly. And it was beat up, and I just ground it for use as a parallel. So for whatever reason, that's exactly 16 millimeters. And these slots are exactly 16 millimeters. And it drops in the slot perfect as a alignment edge, a straight edge, a fence, I guess you'd call it. But because of the nature of T-nuts, they peen the underside of the T-slots. So because this machine is built in the 1930s and is incredibly old, there's just a little bit of peening on the other underside. So this 16 millimeter straight edge, I'm not going to force it. It drops in there, but it doesn't go all the way through. And I kind of just laid it in there, and I've used it as a straight edge to align my my Taft Pierce angle plate. So just another little trick. Once you get some tooling and you get acquire a whole bunch of bits of tooling, it makes your setups just go quick and very easy. And I keep rambling on, but so I started my holes with a hand tap with a nice taper, and after I got halfway through, I actually finished them with a gun point, spiral point tap to make sure I get that good quality thread, because hand taps tend to cut oversized. I just hate it. So this is one of the flatter stones that I own. I know it's a wedge-shaped slipstone, but as far as wet stones go, and this is filthy. I usually keep it clean, and I'll scrub this with a nylon nail brush for your, like a fingernail brush. So this is very flat. Actually, it's a little convex on this side and a little concave maybe on the other side, but less than I'd say it's about a thou out of flat. And you can't grind this flat, but I'm going to grind some regular Norton India stones flat. I wonder if anybody's ever ground an Arkansas stone, which is that ultra fine white stone. Oh, speaking of stones and grinding, I'm going to give you an update on my my storage cabinet. Baby steps. So you remember this cabinet I got from my buddy Jim C. in Grand Island, New York. And I started putting grinding wheels in the cabinet. Alright? Now I got the pegboard hooks. The cheapest for 1/4-inch pegboard hooks was Home Depot. They're like $1. McMaster Carr had them for $3, and I didn't even think that Home Depot would have them. So anyways, I started putting my wheels in, 8-inch, 6-inch, and these are all my 7-inch wheels. And I still got the wings can bolt in as a secondary set of storage devices with the pegboard holes. So that's cool. Been just putting that together. Seeing how I like it. I was going to put shelves in there, just straight across shelving. I got some horizontal milling cutters to hang up. So I figured the gritty wheels I'd put on the bottom, and the horizontal cutters I'd hang up on top. And I bought 10 pegs. I kind of like that. We'll see. So anyhow, that's what I got going on. Until next time, this is Doozer Shop.